We have solved some equations with radicals already. This is our first equation that has two radicals, and it has something that says show that it has an extraneous root. So first of all, we're going to define what does that mean. What is an extraneous root? Best way to describe it, it's an answer that seems to be correct, but isn't. Don't say this is like my entire test. Okay? So an answer that seems to be right, but upon further checking, it isn't. Now this can sometimes happen in radicals because you square both sides. And we'll look at the reason why it happens after we do this question and find out there's an extraneous root in this question. So we have square roots, and in equations with square roots so far, the way that we have gotten rid of those square roots is by squaring both sides. In this case, we have square roots on both sides. They are isolated. We have a square root all by itself on one side. So if I were to, step one, square this side and square this side, then my left-hand side would become 2x minus 5, my right-hand side x minus 7. And combining my like terms, subtract x on both sides. Add 5 to both sides, I get x equals negative 2. Now, to find out if an answer is extraneous, and one of the things that we're going to do with equations that involve radicals is we're going to verify our answer. In example 2, it asked us to verify our answer as part of the question, and it worked. But this time, when I go to verify the answer, and remember the setup we did for verifying the answers, we break up our left side and our right side. We write out the original question, so on the left side it was 2x minus 5. On the right side it was square root of x minus 7. And on the left side we plug in negative 2. What's 2 times negative 2? So I'll plug it in, 2 times negative 2 minus 5. Simplify that. I get square root of negative 9. What do you know about square root of negative 9? Can you do that? That's not possible. So even though we had an answer that seemed to be correct, it's not actually possible to take the square root of negative 9. So this is why this is not a right answer. Even though on the right-hand side, when I plug in negative 2, I get the same thing, we still have to say this answer is not possible. We have to go back, put an x through this, and say there's no solution. I'm going to give you another example of a question which ends up with an extraneous root. So we can call this one A. If you have room, let's call this one B. Okay? Three is equal to 1 minus the square root of x minus 3. So if we were solving this one, we would need to get our square root by itself. Right now the square root is 1 minus this. So I could subtract 1 on both sides because these are like terms. That will give me 2 equals negative square root of x minus 3. And at this point, I could either square both sides, but there's a negative in front. If I wanted to get rid of that negative in front, I could multiply both sides by a -1, and I would get -2 equals the square root of x minus 3. So now I've got my square root by itself. How do you get rid of a square root? Square both sides. What's -2 squared? 4. Equals, square root cancels out, x minus 3. Add 3 to both sides, and you get x equals 7. So this appears to be our answer, but because it's a square root question, we verify what we had on the left side, what we had on the right side. So the left side of this equation originally was just 3. No math needed to be done. On the right side, we had 1 minus the square root of 7 minus 3. What is the square root of 7 minus 3? 4. What's the square root of 4? 2. 1 minus 2. What's 1 minus 2? -1. So in this case, we didn't take the square root of a negative number, but when I check the left side and the right side, they don't match. So that means that even though this appears to be an answer, it's not an answer. It's not possible. So how did I make this question so that that worked? How did I know that the numbers I put in wouldn't work out in the end? Well, if you go back up, right even to the beginning, square roots, whatever answer you get from a square root is always positive. We need 1 minus a positive number to equal 3. Will that ever happen? No. We could have also seen it at this step right here. Square roots are always positive numbers. And what did I have my square root equal to? A -2. That's going to tell me right there that I know that this one's not going to work. Why is it that we get extraneous roots? Well, we get extraneous roots because sometimes when we square both sides, we make two things that aren't equal actually equal. For example, is -2? Well, let's make this more. There we go. -20. Oops. They will be the same if I write the same number. Are -20 and 20 the same numbers? Would you go suntan if it was -20 out? No. Maybe. Okay. Would you go suntan if it was +20 out? Maybe. Maybe it's not quite hot enough. But you'd probably go outside in shorts if it was +20 out, and you would not go outside in shorts if it was -20 out. Okay? But if we square both sides, they're the same. 400 and 400. So sometimes when we square both sides, we make two things that aren't equal, equal, and then that gives us a possibility of getting an extraneous root, which happened in both of these cases. There is one more. We're going to skip example 4, but if you turn to page 144, at the top, we're going to add another example. It's another example with two square roots. But in addition to having these two square roots, we've got another number as well. And these questions sometimes come up on an exam. So far, our basic rule for solving square roots is if you can isolate the square root and square both sides, that gets rid of it. When you have 2 square roots or 3 square roots or 4 square roots or 5 square roots or however many square roots you have, this process might have to repeat. And that's going to be the case in this situation. Can you see that you have the square root of x plus 3 already isolated on the left side? So if I square both sides, that will get rid of the square root on this side. Now I'm going to put brackets around the whole thing, and if I square that whole side, I have to square the whole other side, so I need brackets around that. Now on this side, x plus 3 square root all squared just becomes x plus 3. But on the right-hand side, what does x minus 5 inside of a square root plus 2 all squared mean? Would you agree that it means this? The same thing multiplied by itself? And sometimes this is very helpful to write out. Because the number one mistake students want to make at this situation is just square this and keep going. But if I actually write it out, the same thing multiplied by itself, how do you multiply something like this? You have to FOIL. What does that mean that we're going to get? X plus 3. This times this, well, that will cancel out the square roots, just becomes x minus 5. The outside one, square root of x minus 5 times a plus 2. Inside. And finally 2 times 2 on the outside plus 4. So we started this question with 2 square roots. We squared both sides. Have we made it any simpler? Or is it still just as complicated? It looks like we still have 2 square roots. Could I make this any simpler at this point? Do I have any like terms? Yes. I could put my minus 5 and my 4 together. I could move my x over to the other side. I could move all my numbers over to the other side. So if I brought all my separate numbers over to the other side, that would mean subtracting x on both sides, adding 5 to both sides, subtracting 4 to both sides. What am I going to be left with on the left-hand side? 4. And on the right-hand side, what's left are my square roots. Can you see that those are like radicals? They're like terms. You have 2 of it, and you have 2 more of it. Put that together, you're going to have 4 of them. And we started off with 2 square roots, and after combining like radicals and combining like terms, we now have only 1 square root. So what's the process of solving square roots? You need to isolate 1 square root and then square both sides. Well, we did that once, and that got rid of 1 square root, kept the other one. But now if we do that again, we're going to get rid of all of our square roots. Well, I don't quite have it isolated. What could I do to get rid of the 4 in front? Divide both sides by 4. That will give me 1 equals square root of x minus 5. Square both sides. Careful here. For whatever reason, 1 squared often turns into 2. But check, what's 1 times 1? 1. Add 5 to both sides. And we get x equals 6. Now we've done all that work, but since we have been squaring both sides, we have to check to make sure this wasn't an extraneous root. There's a possibility we did all that work only to find out there was no answer possible. So what does this look like to check? Well, we set it up, put our left side here, our right side here. Our original equation on the left side, we had the square root of x plus 3. And on the right side, we had square root of x minus 5 plus 2. We got an answer of 6. 6 plus 3, square root of 9. The left side simplifies to equal 3. The right-hand side, plug in the 6. Square root of 1 is 1. 1 plus 2 is 3. We got our right-hand side to be equal to 3. We didn't have to take the square root of a negative. Both the left-hand side and the right-hand side are the same. We know this is the answer, and we know that it's correct. Whew. Questions for practice? Question number 10.